It's my distinct pleasure to welcome you all to today's webinar, organized under the auspice of Indian National Academy of Engineering Mumbai chapter. This webinar is yet another initiative on our ongoing effort to bring together academia, industry professionals, researchers to deliberate on issues of national importance. So today's topic, readiness of Indian industry for energy transition, is extremely pertinent in the current context. We are honored to have with us today Mr. Praveen Bhatt, Vice President and Head, Nuclear Business L&T Heavy Engineering, whose presence truly elevates the stature of this event. On behalf of INAE Mumbai chapter, I extend a warm welcome to our esteemed speaker, distinguished INAE fellowships, participants and guests who have joined online as well as found time to be here with us. I now request our chair, Mr. Balasubramanian sir, to take this session forward.
Distinguished INAE fellowships, distinguished invitees, colleagues, friends, ladies and gentlemen, present here as well as who have joined online. Good afternoon to all of you. I would also like to welcome all of you for this webinar organized by Mumbai INAE chapter. Energy transition, as you all know, refers to a fundamental shift in how energy is produced and consumed through carbon-free or carbon minimum resources and methods. Indeed, an approach warranted by the devastating climate changes globally and also due to the need for sustainable development. What it means to a developing country like ours is that on the one hand, there is a continuous increasing demand for energy, which includes electricity, and on the other, a simultaneous challenge of decarbonizing the energy sources. Nuclear energy, which is a clean, reliable, 24/7 safe source of energy, has been given impetus to play a significant role in the energy mix of our country. And the sector is poised for achieving an ambitious target, contributing to the overall energy transition. Energy transition also is a strategic pathway for India to reach its vision of Viksit Bharat by the year 2047, which I must say is a nationally shared common dream of 1.4 billion people. Role of Indian industry in this endeavor is pivotal and can be enhanced through technological innovations, efficient production methodologies, and fostering collaboration and partnership with energy or power utilities, that is between industry and these utilities. Today's talk, titled Readiness of Indian Industry for Energy Transition by our eminent speaker, Mr. Praveen Bhatt, therefore, is a very relevant topic. It's very relevant in the current times and offers a direct industry perspective on the subject. Now, I take great pleasure in introducing our speaker, Mr. Praveen Bhatt. Mr. Praveen Bhatt is Vice President and Head of Nuclear Business at L&T Heavy Engineering. He champions nuclear safety culture and emphasizes first time right execution. We used to say first time right engineering. Now this is first time right execution. Under his leadership, L&T achieved the global benchmark of 33-month delivery for Indian pressurized heavy water reactor steam generators, which, as part of nuclear industry, I know how important it is, and became the first Indian firm certified to ISO 19443 2018, which, as you all know, is with regard to the quality management of nuclear energy supply chain. He has driven digital transformation through Industry 4.0, enhancing efficiency and enabling data-driven decision making. Currently, he leads the first of a kind blanket assembly transporter for the ITER program, that is International Thermonuclear Experimental Reactor at France, reinforcing India's role in global nuclear fusion experiments. He is a recognized voice in manufacturing excellence and smart engineering. I know him as a very competent nuclear professional. So I request Mr. Praveen Bhatt to take over and make his presentation. Thank you very much. So we'll continue with the presentation by Mr. Praveen Bhatt.
So, okay. So they were there when we were explaining. So I was explaining the relevance of the topic, why we picked up. I said the three themes which is going to play out next 5-10 years, irrespective of which country, which part of the world you are. These are energy transition, digital technology, and I said ESG. And some part of E is covered in energy transition, but for sure other ESG part is also going to drive the businesses next 5-10 years. So just to brief, I think most of the people are aware about the L&T, but just a brief on L&T. Is a 87 years old company, basically working 3 verticals: high-tech manufacturing, EPC projects, and services. And I am representing heavy engineering, which is part of high-tech manufacturing. We are basically specialized in manufacturing of critical equipment for nuclear, refinery, petrochemicals, power segment. EPC is a construction and other projects. Services are basically Mindtree, IT services, financial services, those things. Next. Some of the marquee project we did: world tallest statue. Next. Just to give a idea about the L&T, biggest cricket stadium in Ahmedabad, heaviest gas platform for Saudi Aramco, and presently we are doing this world biggest nuclear fusion reactor. We completed our part, then they were struggling for some integration issue at the site, so they approached us, and we will be doing those integration work, which was supposed to be done by a European company, but I think they are not able to do that, so it has been given to us, and will be performing these things during 2027 to 2031, during that period. So what energy transition we are saying, we need a lot of energy. Entire world, we are saying it will be going from nuclear itself is going from 350 gigawatt to 1050 gigawatt. 3-time jump in a nuclear energy itself. There will be requirement of decarbonization, and we are aware that for base load everyone is looking towards nuclear. For sure, we have to compete with the wind, we have to compete with other form of renewable energy, we have to compete with solar, and right now solar is not able to compete with nuclear because of there is no economical solution of battery storage, but people are working, And if battery storage is becoming cheaper, then it will be really a disruptive technology where they'll be the front runner. Next. So what is the relevance to India? We are fourth largest economy, going to be third largest economy very soon after US and China. Our economy is growing at the rate of 6.5, generally last many years between 6 to 7, and we are expected to grow in that rate, 6 to 7%. Though we are third largest electric producer, in fact, consumption wise also we are third in terms of total energy. But if you see, our per capita electricity consumption is very poor. We are 1500, close to 1500 kilowatt per person, which is half of the average of world. And if you compare with the developed country like European Union, they are 6,000, close to 6,000. So we are 1/4 of developed country. In comparison to US, 12,000, they consume 12,000 kilowatt. We are at 1,500. So that is the type of gap. When our PM is saying we'll be a developed country by 2047, which means we'll be in that range. We'll be requiring energy in range of 4,000, 5,000 minimum, that range of kilowatt per person. So there will be a huge requirement of energy. We are a developing nation. That's how our leadership team, they decided, okay, we'll be achieving carbon neutrality by 2070, because we need energy and we need time to become carbon neutral. We cannot stop our development work just to meet this clean energy requirement, but we are committed. There is a declaration by our honorable Prime Minister that 50% energy by 2030 will be renewable. In fact, we are close to that. 100 gigawatt. He declared that 100 gigawatt of nuclear capacity by 2047, which means from 8.8 gigawatt what we are today, we have to jump to 100 gigawatt in next 22 years. It's a huge challenge. We were working out as an industry. It means 4.2 gigawatt addition in every year from now to 2047. What we understood that NPCL is targeting 55 gigawatt, balance 30 gigawatt NTPC and private player. But even for 55 gigawatt is a 2.1 gigawatt, 2.2 gigawatt every year. Today as a L&T, we are at the stage where we can deliver one reactor every year, 4 steam generator, 2 end seal, whatever nuclear island equipment, which means I have to go from 0.7 gigawatt, 700 megawatt to 2.1, 3 times. I have to increase my capacity just to meet the demand of NPCIL. And then there is NTPC, then there will be private player. So there is a huge requirement of manufacturing capability in India. Other things are, I'm sure, is also required, but to make plant you need manufacturing capability. That's how this combination of this topic, and same time there is a huge shortage of skilled manpower. As an industry, we are facing that people are preferring to join Swiggy and Zomato rather than working as a manufacturing person, as a welder, as a fitter. So there is huge challenge for attracting talent, both in in engineer level as well as workman level to manufacturing industry. No one wants to do hardship. They are going for service industry and those type of industry where hardship is less, but a lot of money. People are used to like 5-day working is like hardship. Now they are saying at least 50% work from home, 50% from office. So in that scenario, one side demand is increasing. I have to produce 3 times what I am producing today. Skilled manpower is reducing. What is the solution? And that's why digital and digital manufacturing. So I'll be putting a lot of emphasis on those things in my presentation, because these things are more known to people are attending this program. For sure, India need a change in the way we are doing, the change in the policy. Those are required if you seriously we want to achieve this 100 gigawatt. And what CMD and PCL said, it is not 100 gigawatt, it's at least 100 gigawatt, which means this is the least minimum what is to be achieved. So if we are expecting private sector investment, which is must to achieve 100 gigawatt, then these two things we think that is very important. One is amendment of Atomic Energy Act, that is a policy decision, and second is amendment in CLND. Then only private player, it will look like they'll be, though there are process is already started, they want some captive power plant so that they can compete with European, where they are going to put CBAM tax on steel industry, on cement industry. I think 2027-28 they are still debating, but on a particular date they are going to put tax on industry who are not using green energy. That's how private sector is very much interested to have a clean energy. There is a policy thing also required. I think a lot of funding is required. If you are saying 100 gigawatt and we are saying 20 crore, 22 crore per megawatt, then we can calculate what is the type of funding we are looking. And we need investment, foreign direct investment. We need pension funding. We need different method of funding to fund our 100 gigawatt. And for that, we need some policy decision. Some policy decision already declared that India will be making 5 Indian SMR by 2033, where 22,000 crore has been allocated. But those are like more benefit will be coming later on. Next 5-10 years, it will be like development of those technology. NTPC is coming. That is also good policy decision. I understand they already started with 4151 JV as a SWINI, and later on they are planning to build a large reactor as well as small reactor, as well as they want to replace their existing thermal power plant. Some technology development need to be, because you need to use superheated steam for so you need some technology innovation, but they are working on that direction. Two major challenges why nuclear in the last 70 years in India, why not picked up that much, or across the globe also not very good situation. Only 350 gigawatt across the globe. Issue is that two major is construction time of nuclear power plant and cost overrun. And this is not unique to India. This is not unique to any country. Most of the Western world also, nuclear power plant are delayed. It's not in terms of month or year. It's a 5 years, 6 years type of thing. Right side, you can see that average, what is the average time various country are taking. Most of the country are average, you can see 5 to 10 year, 8 year, 9 years, and maximum is sometime 20 years, 15 years. China is doing in 5 years. They have done in China. They have done in 5 years in Pakistan. Korean, they have done a UAE plant in 5 years. We have done 5 years Tarapur. We have done Kaga. So it's not like 5 years is something like target. We as a country, as an industry, as a BRC, NPCL, together we have achieved this target. And nuclear can be only commercially viable if you are making our nuclear plant in 4.5 years and 5 years. 220 megawatt we are targeting. When we are pitching with a private player, we are saying it should be targeted as a 4 years from first nuclear concrete to certainly some equipment need to be ordered, long lead item, but from first pour concrete to connecting to the grid, 4 years we are working out with them. And for large reactor, at the max 5 years. We are still working out if there is some method to cut down to 4.5 years, 6 months further improvement by modularization, by using technology. So that is the direction. If you are not addressing these two challenges, for sure you will not be able to compete with the other source of energy. And private player, they will be not putting a single rupees where it is not commercially viable. Even in BSR, they are talking, they are putting a lot of discussion, but what they are calculating in background, what is the final rupees per unit, whether it's 7 rupees, 7.5 rupees, 8 rupees, 6 rupees, 5 rupees, what is the cost. Till the time that number is there not known to them, they will not likely to invest as in a big way. Maybe 1 or 2 reactor is a different story, but if you want 15 gigawatt from private sector, then we need to be cost effective. Next. How we are addressing this, what as an industry we are doing. how we are making ourselves ready and addressing these two challenges, reducing cycle time and reducing cost. We got a dedicated facility at INAE Heavy Engineering complex at Hazira, which is basically for manufacturing of nuclear island equipment. And we are saying slowly, even we'll see that whether we can do BOP, balance of plant, some of the critical balance of plant equipment. So this is the facility. Right now, if you can see in this, there are 6 heavy shops. Presently, only one heavy bay is being used for nuclear. Only one heavy bay and one medium fabrication bay. So, to some extent, suppose you say infrastructure wise, if I want to triple the capacity of nuclear island equipment, it's not a big issue from infrastructure point of view, because it's still 4 bay, 3 bay, 1 bay for defense and 3 bay for oil and gas. Slowly, for sure, we know that oil and gas business going to go down. People are like, it's like coal and oil is people not like to speak in the meeting. We are doing oil reactor, oil gas reactor, coal plant. So infrastructure wise, we are ready. Next. But you need more than infrastructure for doing a nuclear. You cannot, you can invest 2,000 crore, 4,000 crore infrastructure in 24 months. Maximum cycle time to build an infrastructure is 24 months. Today you decided to build an infrastructure equivalent to maybe L&T, you need 24 to 30 months, that's all. But you need more than that in nuclear. You need a track record, and L&T with a 6 decades of partnership with DAE started with, I think, Dhruva reactor. Someone selling 40 years completed of Dhruva reactor yesterday. So from Dhruva reactor, 220 megawatt, 540 megawatt, 700 megawatt, PFBR, Bhamini program, ITER, in all Indian program, L&T is participating, has participated. In all 25 reactor, we are having footprint, either through equipment or through construction or some way. So we got a track record, and you need a track record. In the industry, I'm sure if some industry people are sitting and listening, nuclear doesn't happen overnight, and you have to build a track record, and you should have a perseverance, patience, and it will take time. It will, no one has achieved success in first go. You can learn from the industry who are leading in this, but certainly you need a patience. So we are basically saying we are going to support this 100 gigawatt program for nuclear island equipment as a heavy engineering side. Similarly, construction side will be supporting this program. We are building the capability. This is like presently we are building all nuclear island equipment practically at our Hazira workshop, and people who are attending and wish to see all those getting manufactured together, they are most welcome. They are most welcome to see those our facility. This is the thing we are saying we are working on. Reducing cycle time drastically. I just said the key success factor of nuclear energy will be reducing cycle time and cost, and we are working on that direction. Where steam generator, we used to take 84 months. Kakrapar first steam generator delivered in 84 months. From 84 months, I came down to 4 SG in 45 months. First SG in 33 months. Gorakhpur we achieved 36 months. Further improved to 33 months, and we are working continuously on that. And we are very confident that steam generator can be delivered in a 28 to 30 months without compromising on anything. Even I'm saying without changing the even stage inspection, without changing anything. Only thing, waiting time here, and I'm saying still without technology, using big IoTs and automation. With same technology, with same manufacturing thing, it can be further reduced 2 to 3 months by just addressing holdups at industry. But 30 months will not solve our purpose of going 100 gigawatt. Then we need the technology. Next. Another component like NCL, we have reduced from 56 to 31 months. So these two were used to be the critical component deciding that overall cycle time and nuclear power plant. For sure, at least in fleet program, we can convey that these equipment are not going to be a constraint anymore. So for nuclear, what we are doing, first thing, you need a very, very strong culture if you want to be in a nuclear industry. Without culture, nothing can happen. You can buy machine, you can even hire people, you can attract talent by paying high, but culture is the thing where you have to work over many years. It cannot be built overnight, and you need to, and language should be from topmost leadership to the blue collar workman. Everyone should speak same language, then only this culture gets built up. Otherwise, if you are speaking something in a meeting and one is to one, you are speaking different language, it will be never a success story. Then first of a kind initiative, wherever is a first of the kind, you need extensive mock-up, you need extensive effort in developing the process rather than going direct. That is the key for nuclear. We have done some backward integration which is helping us, like most of the forging we are getting from our own core shop. Lot of machining facility we have developed, so sometime to get control on small component, backward integration is a good approach in nuclear. You, instead of sending item to vendor, you ask vendor to put machine in your facility. That's the way there are a lot of control. Vendor development, again, very, very important for one good thing happened, sir, over last many years. What we did, 700 megawatt complete indigenization of the item. Not a single nut to be procured from abroad. If you decide for commercial purpose, for cycle time, you can decide to go to abroad, you can decide to import. But technology wise, you need not to go to. Everything is for steam generator and still developed. Only in pressurizer, one component of heater where we are still working out with NPCL, and for sure we have to develop that component. And forging of reactor header, there we have to just start that. We are having capability, but steam generator and still, and that helped a lot in reducing cycle time, because you depend most of the time. Big component is always available, forging, tube sheet, cell. uh, Problem is always a smaller component, vanes and separator, and this tie rod, this fastener, junge bolt. Those things creates a havoc. So what we decided is started developing vendor ecosystem and long-term partnership. It's not like now, like most of the vendor, we don't go tendering route or L1, L2. They are our long-term partner. Some of the machining vendor we have like having long-term MOU. We book their capacity permanently, and we are working on that line, same line. You cannot do everything in house, but you have to find right partner, do development and handhold. If he's not having work, you have to give work from other sector, or you have to pay something something so that he can survive, because these are the mostly MSME. So those type of approach is very much required for long association. My main topic which I am going to show, that is adoption of industry 4.1. For sure, I can tell my experience is very less. I am only in 8 year in nuclear, 30 years in L&T, joined as a PGT from IIT BHU, and this is my only company. But people are here, they are much more experienced in nuclear. But in 8 years, what I learned, this, if you want to triple the capacity, reliability in present environment where skilled manpower is the challenge, adoption of technology is the only method, only way we can achieve this target, by adoption of technology, new technology. And we call it industry 4.0. In fact, now industry 5.0 or 5.0 is being talked. Training and retaining nuclear talent pool is very, very much important. You can de-skill by using technology, but finally you can de-skill to some level. You cannot replace everything. So some brief what we did in the last 6 years for industry to follow. We started monitoring nuclear culture, not only saying that we should maintain culture. We started monitoring, and some points in terms of what is the transparency level, what is the first time right approach, how much a document compliance, some method. But every industry has to see that how they are critically monitoring the culture, not only through talk and through that, whether you can measure and monitor. And anything you are monitoring, it will improve for sure. We started at 650. I remember 2018 when we did first time, it was 650. Then we went to 850, tightened the scale further, and now we are at the rate of 850. We are expecting year again will tighten further the scale so that you start a base at 600, 650 and keep on improving. Next. So quality, the only way to expedite nuclear equipment, nuclear construction is focusing on first time right. The more you push cycle time, the more you try to reduce cycle time, it increases. So we have to focus, if you are in a nuclear industry, on quality. This is the one of the most critical thing of a steam generator overlay on a tube seat. We used to get 100, 60, 50 defects, and then months of RCA and repair and rework, and customer is also not happy. Finally, he's clearing with those repair. Gorakhpur, fourth steam generator, we got it right. One defects only in entire surface, and then almost consistently 0, 1, 3 single digit. Similarly, tube seat drillings, from 71 NCR in tube seat drilling to 08 tube seat we have drilled. So there is no mantra other than this for success in a nuclear. Focus on quality, learn from the past, don't hurry up, you'll get it right. And you'll all of a sudden you'll realize that you have saved 3 months, 4 months in cycle time. See the type of non-conformity we have reduced from 274 to 221. These are like 4 set of steam generator. From there 18, and very strong customer connect, involving customer. What we learned in nuclear, sir, to everyone, nuclear is not brilliance of one person, and we are not writing code, or we are not doing some at least in manufacturing. It's a like a collaboration, is a approach where a collaborative approach between customer, vendor, manufacturing people, maybe not very high flyer, but they are together, and together they are making decision moving hand. That is the key for nuclear. So one brilliant person may not help in much in nuclear manufacturing, rather than 10 people ready to work together and ready to understand what is the requirement of the product. Next. Same end seal, we are manufacturing right now 4 end seal, and in the first KAGA, which is in final stage, final machining is going on to NCR, and Gorakhpur right now bi-junction joint is going on. There is no NCR in end seals. Next. We have done some backward integration, as I said. Almost all the forging and plate of SGNSS I can get from my own forging shop, and that helped a lot. So pressurizer, end seal, steam generator, we are delivering to NPCL also, and plus directly also I'm procuring from them. Next. As I said, a lot of efforts in indigenization. This is helping as a program. We have to see that few component which is left out still in 700 megawatt. We have to see that how to focus on that as a industry, as a NPCL will together will work out, so that we are not depending on, because in today's world we don't know who stops when. So it's a really dicey situation. We got a good engineering thing. Most of the engineering is always done by the customer in BRC program, by BRC, NPCL. But we got a good, and when 700 megawatt thermal hydraulics, we had a problem of again sanction, and software was not being given by the German. We developed along with IIT Bombay. So you got in-house skill where we can deal with all those things wherever is required. Next. And we had developed some really, as I said, good vendor with whom we worked a lot. They also made a lot of mistake. They invested heavily. MNS, Bharat Forge, they invested really in developing DG steel. They lost money in first project, second project, but they were there. They were supporting the program. They were supporting that. They knew that nuclear is going to be big in MNS. When first time we spoke to him, 16 MO3 plate, some few tonnage, he said, I am producing steel in million ton. you're talking about some 10, 10, 20, 10, and you're saying every plate to be spread out for UT. I am doing online UT. People are every day I'm giving 500 ton to someone. But then we explained what is the region and industrial export, importing and problem. And he came along. Now I think he's giving to everyone. BHL, Godrej, L&T, everyone preparing from him 16 number 3 plate. So coming to my main what we have done and what is the future for achieving this very very ambitious target is Industry 4.0. So we know that we started this journey, sir, in 2017-18. 2017-18, before Corona. Actually, we never knew that we will be requiring and needing these things. But we thought all of a sudden we got order of 3 times reactor from oil and gas side. And we thought it's not possible to do. Then as a team, we said, we gave a name, doubling the capacity. How to double the capacity with the same space and same infrastructure. And that's how this digital journey started. And we started getting success. So right now there are more than 100 connected machine. When I'm saying connected machine, all this machine, everything 24/7 accessible to our customer, to shop in charges. So voltage, current, speed, temperature, their arcing time. And to our surprise, we found that baselining, we were doing only 3.5 hours in 8 hours shift, average 3 hours, 3.5 hours of welding only. Actual arcing, though when work people are booking 8 hours, 8 hour works on that, but final arcing was only 3.5 hours. Because every second if it arcing, it is getting recorded. Similarly, machining, to our surprise, horizontal bore only 22 to 23% actual cutting time, because we are capturing when current is high. When metal is being removed, current will be high. Other time machine is running, so for someone 8 hours working, but actual removal is only 22%. So that is the type of opportunity we found when we started using this digital technology. Next. So just a brief. So there are a lot of sensor technology where all those parameters you have to capture. There is an integrated platform. You need a lot of investment in infrastructure. We invested approximately 30-40 crore just to get Wi-Fi across the campus. So server, Wi-Fi, we evaluated all 5G and 4G and PLT. We called it Nokia, Vodafone, but finally we went with a 5G technology. Entire campus with a Wi-Fi from all machines are connected. Lot of focus need to be done on cyber security, because second biggest thing is happening, a lot of thing happening on cyber security side. So both are working. People who are attacking, they are also putting a lot of investment, and people who are so we got a dedicated IT security, dedicated OT security, and sometimes there are physical separation. Sometimes security through segregation through software, but some places it's a physical segregation, IT and OT. So those type of things are, and then there are platform like IMQS is our equivalent to PLM. NPCL team, all those documents, online documents, the day we give SRN, same day we submit all the documents. So online documentation of entire thing. ERP, everyone is aware, IoT database, and lot of data analytics we are able to do it based upon these data. Next. So you can see that there are 3, it's like equivalent to primary head being overlaid by Inconel. Person is sitting in this cockpit with 3 screen, all the control here, and he is welding all 3 head. Earlier when I joined, 2 people were sitting in a head which is heated 150 degree. On inside head, he is also getting heated. From there, he's sitting in AC cabin and doing all the welding, and 1 person 3. So 6 is reduced to 1. That is the type of improvement. Plus 3.5 hour arcing has gone to 6.5 hours. People made a benchmark of 8 hours. They did not go to lunch to make a benchmark. They ate banana and be there in 8 hours to just get a certificate. But on an average, 6.5 hours is possible in 8 hours. So this is our own steam generator where overlay station we have developed. You see right side, I remember again one by one welding up these lugs. Then for turning, because you want flatness, you have to turn it down, do post heating, remove from the station, turn it, then again heat. Now this facility, this station is having upside down facility. You can turn it down there during heating condition only, and two people in sitting in AC cabin are welding those lugs. So that's the type of improvement. Next. Similarly, rib. So lot of innovation, and how we are doing, and it's learning to everyone. We got a like manufacturing technology department. They are not project people. They are not responsible for any other thing. They are 10, 20 bright, smart people, electronics, electrical, mechanical, and they are doing only this technology development. Suppose I'm getting steam generator project. I need a robotic welding. One A4 size paper I'll fill up and I'll give it to them. I need this. This is the technology. This is the process I want. This is type of improvement. And that paper, they'll start working from the fundamental. Their role is to develop the technology, proof of concept, proving the everything, and then handing over to shop. That model is working very good, and that is our core. That is helping us to develop new technology. Next. This is right side is a primary head. When 2018, I saw that we need two primary head, because I need to balance it, one on one side, second is another side, and it was rotating on tank rotator. And for every nozzle, this is like hand, where every movement you can do, all 5 axis movement you can do, and everything can be welded in one setup with IoT, where you can record current, voltage, everything. So these type of improvement. So technology, using technology to improve productivity, and more important, and is reliability. You are de-skilling. You are not depending on the good quality welder. He is qualified to operate the machine, but machine will produce same result every time without any like he is not going to get key, I'm not able to work more than 4 hours, I'm feeling fatigue and all those things. Next. See the type of left side. This is the shop, like any shopping mall. This entire shop is just to do overlay on ID of the nozzle for oil and gas. In our, we don't have that so much in nuclear, but like 250 nozzle to be overlaid in a month. So this is the type of shop we developed. One person can operate 8 machine, and it's like a welder has to put his I card, then only that machine, that switch on, also he cannot do without putting his I card. Then he has to scan the code of the electrode. Once he is matching with the requirement given by building, then only that machine will be he'll be able to operate. Those type of interlocking, so that quality is also inbuilt in these stations. Next. See this. So all this picture in-house designed and developed. So it's a fixture where I want to do long seam in a primary head. Earlier, I don't know how many setup, 8, 10 setup to do all 4, 5, 6 welding. Now in one setup, person is sitting in a AC cabin on top, and from there he's once he is going 6:30, 7 o'clock, even flux will be delivered there, consumer will be delivered there, he'll be sitting there and operating entire thing. Next. Then similar station for long seam, suck seam, for heat exchanger in other shop. We started similar one man doing multiple station for overlay on cell ID. So person can sit and do welding at from remote location. Next.
This solution uses robotic gas metal arc welding, GMAW,
is on robotic welding. You can continue.
To cut cycle time by up to 50%. It features a manipulator for precise movement, a robotic cell for efficient operation, and a preheating arrangement for optimal welding temperature. The robot's vision system ensures precise tool placement, and an automatic tool changer selects the right tools for each task. This technology delivers faster, more efficient, and higher quality welding, perfect for large-scale column welding.
He can weld, job is rotating. So those type of innovation. We are putting center of excellence for robotics. Two things, as I said, in digital IoTs and PLM, these are out. People, like, I'm not saying outdated. People who are not implemented, even those are like. I was in a conference. The digital person said, if you're saying I'm going to implement PLM, IoT, then you are saying I'm going to buy color TV. That is the type of thing has become IoT. And next is robotic and AI. So we have to, all industry, whoever is working on digital technology, trying to use this technology, they have to work on these AI. Lot of challenges on AI side. We said jokingly that how hierarchy is going to maintain, we don't know. 30 years I worked in L&T. What is my, why I am vice president? Because I got experience and knowledge of 30 years. Today with AI, myself and GT are both are same level. I don't know how we are going to maintain hierarchy between, maybe he's more having more information with good skill in. A lot of work we have done. We also said
phased array ultrasonic testing is a cutting-edge technique for inspecting weld joints, providing high-resolution data to identify even the tiniest imperfections. LNT-AMNHEC processes about 10 kilometers of PUT data annually, which has been challenging to interpret efficiently by a highly skilled workforce. To address this, we collaborated with Funny AI and IIT Madras's CNDE to develop an AI-based automated defect recognition system as a part of digital initiatives. After almost 100 hours of technical discussions, annotation and AI training of around 1 kilometer of PUT scan files, and testing on another half kilometer of PUT scan files, we launched the AI-based automated defect recognition system for PUT data analysis on November 28, 2024, for the first time in the heavy fabrication industry. Evolved with 100% probability of detection and 100% sizing accuracy, the ADR system uses advanced algorithms to detect, classify, and highlight defects, offering detailed reports with an enhanced user interface and color coding for quick decisions. Key benefits include enhanced accuracy, faster analysis, 3D visualization, desk killing, detailed digital coordinates, improved reporting, and scalability. For end customers, it offers precise evaluation of complex data, reliable data for future inspections, and better asset integrity management, and data-driven insights for predictive maintenance. Integrating ADR into our PUT process enhances.
This is the new thing we are working out. We said 1 man 3 station, 1 man 6 station. We thought, why not welderless, no welder? So we are trying to capture through AI what he does. He position the current voltage anyway is automatically controlled. He position the tip of the welding machine. So we are mimicking that, how to position based upon that gap and thing. We are working out 2 or 3 suction we have welded. One challenge was how to remove flux and all those things. So that also we have developed. So this is the next stage where we are saying even one welder is also not required, or he can be on the ground and 6-7 thing he can build simultaneously, just to see that there is no stoppage, there is no problem, nothing. We call it autonomous welding. So basically, automatic bead placement is the main. Slag and wire cutting, SAW, you have to cut wire after some time. So those things we are automating. So this is also possible. Automatic setup station we have developed, where 2 cell we can do automatic setup station by measuring using laser. Next. This is the cobot we have developed for ultrasound. You can do using these cobots. It goes around the sheet and collect the data. That data is fed to our server, where you can do AI-based evaluation of the end. So this is developed with, again, one startup company and our own manufacturing technology team. Next. Inspection, as I said, we are using in big way. Slowly we are introducing in nuclear also, doing like calibration. We are doing by both method, first by conventional method and by digital method, comparing the data, showing that consistency. But finally, I think this is the way. Digital metrology is the way. ASME is already started accepting like circularity data. We scan everything, compare with the model, and deviation will be, and we put as a code case, and they accepted that. So in oil and gas, we have started using digital technology for measurement. And best point is that is a scanning of the surface. So it's not like point scanning. Even in manual method, you check some points, but there can be high points. But it's a scanning of surface, so surface to surface comparison. Next. So circularity data, whole locations and all entire thing we are using. Oil and gas side 100% using this laser scanning, and this is very fast evolving. Every 2 years, 3 years, new technology is coming in metrology. Distant inspection, cell inspection, shape inspection, all those are we are using digital metrology. Next. This is our own separator. We did a steam separator. We started using virtual assembly rather than doing physical assembly in heat exchanger, tube bundle, whether tube bundle will foul during insertion. So in a nuclear steam generator, we did for a steam separator, we did a virtual mock-up. Though as per our procedure right now, we have to do physical also, but we just calibrated the two result, whether is so that in future we can replace manual with this digital technology. Next. Digital setup, you can see that in bottom center one. Laser is giving projection that location of the lug, and then he can do setup. So we are using even for setup purpose these technology. Next. So now we are working automated report generation. The way customer is needing in a particular format. Suppose I am doing the inspection using Polyworks, in same format how to generate report. So that automation we are doing. So we got two departments. One is manufacturing technology, hardcore technology, welding and those mechanical part. And one is digital technology team who are working on AI, data analytics on those. So these two separate departments full-time working for improving productivity. That is the core. And most of the geographic engineer, two things we are solving. One, they are not liking to work on shop floor and they are leaving. So we are saying there is a place if your interest is in IT, technology, digital twin, be in this department. So we are able to retain, plus they are solving our problem. Thank you, sir. I thought these are the things what we are doing there. Two things which was not covered because it's not still implemented, as I said, in full way, that is robotics and AI in data analytics. So we expect that 40-50 robots at least should work in our premises. So there is a shop is being dedicated for Central of Excellence as robotics for developing application. Similarly on AI, lot of data is getting generated through IoTs and platform, but how to use those data? There are safety related data, quality related data, which welder I should position based on his track record, whether in third shift we are getting more defects, whether in a particular time post lunch, before lunch, lot of defects. Type of analytics we are trying to do, so that while deploying people, while assigning work, you can see that how to, whether जब भी शिफ्ट छूटता है उसके आधे घंटे पहले वाले में lot of defects are coming because he is in a hurry to go home and not giving charge. Those type of analysis is also now possible with these things. In fact, IIT Kharagpur is developing, we are working with them, where he can, based on face recognition, he can find out whether he's feeling fatigue and likely to make defects in NCR. So camera will keep on scanning and he'll give an alarm that a person is like feeling drowsy and he can make a mistake, those type of things. So there is no end to AI, but for sure we need this technology to triple our capacity. If you want to go from X to Y, triple total energy, and our target is anywhere from 9 gigawatt to 100, so 10 times. So certainly we need. Thank you, sir. Thank you for giving this.
Thank you very much, Mr. Praveen Bhatt, for the excellent technical presentation. In a lighter way, I was thinking how to shift a worker from the actual work to a AC room. That's what the technological innovation is bringing in, of course, in a lighter way, but then how the productivity, how the quality improvements are achieved. He has taken us through a very interesting journey to make us understand the possibilities of technological innovations in the days to come. Before we take up questions, may I request Dr. R.B. Grover to say a few words related.
Well, thank you, Bala. This was an interesting lecture, and this transition is an important topic. And for a country like India, which has to simultaneously develop and transition, this transition has to be a development-led transition. And I did see a hint of this kind of approach in what Praveen Bhatt has just spoken to us. Another thing which is going to happen as we proceed further, energy sector at the moment in India as well as globally is fragmented. You have petroleum, you have gas, you have electricity, you have coal. It's a fragmented sector. Now, when we want to transition to low carbon technologies like nuclear, solar, wind, hydro, they give you electricity. So electrification is going to be a considerable part moving forward. And current electrification in India, if you see final energy consumption, 22% of final energy consumption is in the form of electricity. And expectation is that if we want to transition to a low carbon economy, by say 2047, I want to become a developed country also, this has to go to as high as 60%. And moving forward, maybe beyond that. So there is going to be integration of the energy system through electrification. I think this is a very important point which is going to emerge as we proceed further. And nuclear has a role to play in all this as a base load station. I think there are several challenges which have been highlighted by Mr. Praveen Bhatt. And I think one thing which I sort of resonate with my thinking, which Praveen said right in the beginning, it's challenges in attracting skilled manpower to manufacturing industry. And Bala, you also have said it in a way that the worker has to be moved to air-conditioned cabin, which may not be that easy. But yes, this attracting skilled manpower to manufacturing industry is going to be a big challenge moving forward. In case of nuclear, there is going to be another challenge. Getting OMN personnel for plants which will be located in remote areas, that also is going to be a challenge. And everyone wants to live in metro cities, and nuclear plants are not in metro cities, and they are not going to be in metro cities. So these are the challenges which are non-technical, but they might play a dominant role moving forward. There is a talk about privatization, which is going to happen soon, enabled by change of legislation, which is an ongoing work. But one thing which I wonder, which I have not seen anyone writing about, in nuclear, we go for 30-70 investment, 30 equity, 70 is the debt component, which comes from the banking sector. Whether it is private or public sector, the 70 has to come from the banking sector. So I think we have to think of that as well, as to how is that 70% which is going to be provided by the banking sector, we will be able to generate that kind of savings in the country that which is directed to this sector. It's not only true of nuclear, whatever energy, we need more energy, but everywhere this challenge is something which we'll have to overcome as we proceed further. I think he also talked about construction time and cost and gave example of China, South Korea, India, where it has been demonstrated that projects can be there in 5 years. By the way, there is a, in last 10-15 days or so, there's a paper in Nature which talks about how China, they have been able to bring time to 5 years, 5.5 years. It's only 2 pages, but nice summary of the complete data. It's worth having a look for you. And one thing very encouraging, which you said, is it takes 24 months to build infrastructure. That is not too long. I think once we decide, take a decision, policy decision, we can move forward. And adoption of Industry 4.0, collaboration between stakeholders, IoT, cybersecurity, dedicated technology group, that I think is a good initiative which you talked about. Autonomous welding and boats for UT. I think moving forward, your lecture gives confidence. Yes, manufacturing industry is getting ready for 100 gigawatt by 2047. Hopefully, we'll be able to achieve it moving forward. Thank you.
Thank you, sir.
Thank you, sir, for the overall observations, overall strategies. Thank you. And now the session is open for questions.
I have a few very general queries.
Yes, sir, switch on the mic there. Yes.
I have some general queries. See, it is very heartening to see the technology is playing very important role in expanding the infrastructure. But I think the task ahead is very mammoth actually. I mean, almost 10 times you want to go up. So what I first want to understand is, do you think more players will be required like yourself to do the job actually? And you call it competitor or your other colleagues, are they ready to invest the way L&T has already done this type of infrastructure establishment and trying to expand it actually? I think it is very critical actually that should be other players like yourself who can take up these challenges. And also, just tell me how practical things are. Government makes a lot of announcements. But unless what Grover Saab is telling, the 30-70 type of thing actually, and that eventually comes from how the economy is growing in this country actually. The banking sector also develops because of the economy and all that. Are we really going to see such things happening in the years to come? Say 22 years we are talking 47, but how do you see this scenario in next 10 years actually?
So,
He is Dr. V.K. Muthandar, President, Indian Resources.
okay. Thank you, sir. So, for sure, this target is very, very ambitious, especially with our track record, the way we built last 2 decades, 3 decades. And you are correct. We need an ecosystem to develop 100 gigawatt, not one manufacturing company or one stakeholder can do this type of thing. But same time, this is being done across other part of the world. China is building even bigger than this. More gigawatt he's adding, more reactor he's planning to add in next 20 years.
Where is China and where is India?
Correct. So two things. One is for sure we need a lot of political will if we want to go to 100 gigawatt. We need different approach. We need different approach in terms of we are executing project. We need ecosystem, many players. It depends how a private player enters in a market when they see there is the money, and then they need almost assured. They are assured that they are going to make money. They are going to get business. Right now, people are not that clear. They are still skeptical. People are saying it will happen. They are trying to gauge whether it will happen, how much it will happen, what is the real mood. If you see solar, how it picked up in India, how investment happened, when they started seeing that there is economy, there is a will, and there is a possibility of doing it. Gigawatt over gigawatt, and it came down to 2.8 rupees type of thing. Right now, people from industry side, I'll tell private industry, private investor, they are seeing whether this is going to happen or not going to happen. They are gauging that. One good thing happened, like many players are now talking. Earlier, everything was with NPCL and with a constrained resource and number of people, number of projects they can handle. It was really a thing. But with the NTPCs coming, so there is a funding ka bhi thoda problem solve ho raha hai. Then Adani, Reliance, GSW, Hindalco, Vedanta, 4 into 700 putting by GSW Adani is not a big deal. They anywhere Adani gave order for, they are building 6, they have given to BHEL for 800 megawatt thermal and 12 to L&T few months back. They saw that this is not happening and the people, we need base load, so they are putting that fund there. So funding, in my opinion, from private sector, 15 gigawatt will not be a big deal. If a target of out of 115 gigawatt only from a private sector side, and with Adani, Reliance, and they are anyway going to pay taxes as a CBAM if they are not investing in green energy. So they are desperate to get a green energy, and in next 5-6 years they are not likely to get a storage solution where solar energy can be stored or can be given to steel mill. Now we have to see that how fast we are able to engage these people. If we promised this monsoon session this should happen, but it's not happening. I think today and tomorrow is the last day. If it is not happening fast and it's taking time, again it will be there where people have shown interest. At least last 5-6 months I have met minimum 10-15 team of private big company where they are saying we are ready, we want to put. They are only asking 2 questions: can you build in 4.5 years and 5 years, and give me workout what is the per rupees unit finally. If it is 6 rupees and you are saying 5 years you can build and hand over, take this money and hand over me after 5 years with this cost, which is right now a challenge, both in terms of cycle time and meeting those rupees and 6 rupees type of target. So I think if people see success, you'll see direction. Funding is not going to be that much challenge. Bigger challenge will be this decision making, bringing them on board and making industry ready to support that type of program. And we need mammoth change, transformation to reach that type of target.
We named few private players who are looking towards the government and the amendments so that they can really, invest something. But my question was different. So that is one part of it. Good, you actually clarified that. See, you are not putting your money. You are working for NPCL right now. So I was more referring to.
No, I'm saying even like industry, they are ready to invest. Like many company right now talking to NTPC, Vedanta to put some equity, 20%, 30%, 40%, owning the plant and getting return when electricity is getting generated.
Like L&T?
Like L&T.
Okay, so
but
there are many.
They'll be in that mode when they'll say there is amendment, there is a fuel security, there is a government supporting the program. So they are working out, but it will be only feasible once they'll see that type of a momentum.
The type of infrastructure that L&T possesses, how many companies in India are currently possessing and how many may join further? That is what I wanted to.
But joining, I'll tell you, once there is a business, there are people to join. There are people to join.
You see that what happened in China from 95 to 2000 onwards. From nothing, they immediately came up. Same thing can happen here also. It is not impossible.
Sir, Indian politics is very complex.
No, I think let's not talk about politics.
Very complex. China doesn't have that politics.
Yeah, so
given the advances that have happened in the Indian industry, I'm not talking about utilities. I'm talking about the manufacturing, construction type of industries. It can happen because today we are in a position. We means the Indian industry is in a position to deliver.
Yeah,
so that's what.
And let's give a chance to others to ask questions.
Yes.
Bala,
Yes, sir.
Can I start a question?
Please.
Sanat Kumar here. Okay.
Yes, sir.
as Dr. Grover said, we'll change the topic totally. We've been talking about this too much. So I will first of all begin by saying, as a old timer, I'm simply astounded by your lecture. It was fantastic. It's an eye opener for me. Okay. Then I will be very brief. Your excellent was very good. Well, there were some other slides on which I wish you had spent more time, but doesn't matter. All that robotics, it will go on and on and on. That doesn't matter. I want to tell you one story. Then I will ask you my question. In around 1976 or so, 1976, 1977, when I was working on the fueling machines, shielding plugs and sealing plugs, I happened to go to Canada for, there were some problems, and then they said, you come here, we'll do. Hiru is the company, Canadian company, who were doing this sealing and shielding plugs. So I went there to see. They would not let me in because they had a glass door. You see everything from here, you cannot go inside. They were so much afraid of me. But nevertheless, what I saw was the entire floor full of robots operating on milling machines and grinding machines and lathes, simple things, doing shielding plug operations. So our shielding plug requirement for 650 numbers per reactor. That was no issue for him. He'll do it. So I wanted to say, you are getting, after 25 years or so now, you are getting into that stage, which is very good. That is what I wanted to appreciate. You are getting into a whole assembly line full of robotics. But this is a question that is coming. You showed 6 shops with the blue roofs, and then you said one shop only is occupied, the remaining are not fully occupied in terms of machine hours or in terms of productivity. My question is, are you not competing abroad? That is, say Westinghouse wants a component to be made, or Areva wants a component to be made. You are making ITR, I understand. But are you prevented from any international, Grover may know, are you prevented from any international rule that you cannot quote for nuclear component? You may be able to quote for so many other road rollers, for example. But can you not quote for similar? They also need pressure vessels. But are there pressure vessels thickness wise beyond your limitation? They need, I think, 10 inches or 250 millimeters. I don't know.
Yes.
So is it so? This is the question.
Yes. So, sir, as I said, one is being used for nuclear, other are being used for oil and gas because there is no enough nuclear road from domestic. But question is correct. Why not global? Because a lot of reactors being happening. Initially, Westinghouse and India both spoke to us for Indian program, Jaitapur and Kowada, and they qualified us. We did all the mock-up, technology development. In fact, what I remember, we were about to sign JV, and even officers were selected where that JV will sit in Visakhapatnam. From there, they went to bankruptcy and all those things. So technology-wise, they have qualified us for Indian program. Then for global program, they said they need PTR for nuclear island equipment, and that process is on. QSL is all, ASL is happened, QSL will happening. But US one problem is facing 810 authorization is must. And we are talking to US like those business group who are coming, embassy. Right now, they are taking months and months for 810
I didn't
authorization.
get that word. What is the authorization you wanted from US? What is the authorization?
810 authorization.
Sorry?
810 authorization.
Oh, okay. Okay.
It's a 810 authorization as per their DA regulation. Even for doing physical meeting with me on nuclear subject, they need their permission from DA that they can talk to L&T on a thing. And that process, like Haltech somehow, our Prime Minister went there, Haltech applied, and somehow in 2-3 months they got that permission, 810 authorization for SMR. But for large reactor, there is still, even with all those G2G, the process of 810 authorization, sharing of drawing is very, very slow. But they are considering us. We have developed one small component for Westinghouse. We are working with them for balance of plant. They are saying you start with feed water and those heat exchanger tank or secondary side. Then we'll introduce to one problem is that all these players are saying you sign exclusivity with me. Means if you are doing with me, since I'm helping you in technology, you will not work with EDF. EDF will say then, and presently our stand is we are technology neutral.
Exactly.
I'm doing for everyone.
Yes.
But let's see how far I am able to stand on that thing. Whether one day, since because of that, everything Westinghouse going to Doosan, EDF is going to Framatome. That problem we are facing, but we are working with them. We are qualified by both EDF and.
I appreciate your view. That's correct. That's why you want to get tied up to one fellow. That's not correct. Yeah, correct. That's right.
So we are holding that ground. Mr. Parav is saying we'll be technology neutral. If they want to come, okay. If I'm having tie-up with some, I can give him some preferential thing in giving code faster, maybe some benefit, but I cannot tie up. He is asking exclusivity for many years. For minimum, I think 10 years, he will not work with anyone else, something like that. So, but we are working with them. And in fact, our, though is still under debate discussion, our growth, what we are expecting nuclear next 5 years, is mainly coming, we are saying, through international nuclear program.
Maybe
domestic, we know that it will be a steady rate.
Maybe you can spin off a separate group under L&T kind of thing, and they are married to those fellows, and they cannot talk to anybody. Maybe that can.
I agree.
Yeah.
Correct.
Thank you very much.
We are working out that how to, but certainly, sir, our main 5-year plans, that number one strategy is going global in nuclear, and competing with Korean. Doosan Innerability is the number one today, serving all technology.
Thank you.
So we take up the next question, Mr. Hegde. Thank you. Mr. Hegde?
Yeah,
please go
thank you, Mr. Bhatt, for that excellent presentation. I come from the industry, basically from the structural engineering side. I was also involved in the construction of this Kalpakam as well as, Kaiga, some of the works on behalf of Gammon. When I was there in Gammon, I was involved in that. You see, the thing is, recently in the recent past, they have privatized, they are going as a policy, they are trying to privatize small nuclear plants. They are saying that they want to give it to, I don't understand the difference between the small nuclear plants as well as the large nuclear plants, but that's what I understand from the policy makers, that they're going to do that. When I was involved in this Kalpakam as well as Kaiga, some of the works which I was involved in, at that time, the technology was not it was not a Swadeshi technology. It's not always, it was told that it's a Russian technology or German the French technology, and it was not sort of an Indian, to say that it's the Indian technology. Even for that matter, even the structural design of the containment structure at that particular point of time, it was, borrowed from Russia, something like that. Nowadays, of course, we are doing it. That's there. But as far as the, this, your steam generator and all sort of a mechanical component design is concerned, for the nuclear design is concerned, is it? Have we started doing it indigenously right now? This technologies has been developed indigenously. If it is not developed indigenously, we are going to private. You are going to privatize. Basically, the nuclear power plants, small nuclear power plants, are going to be given to private parties. That's what I understand. How are they going to do it if it is not? We do not have the indigenous.
So what? Sir, what my understanding is that nuclear physics part of the thing will remain with BRC and NPCIL, even for private player. That part is not going to go to private sector as on date. What is the plan? Mechanical design, detail engineering, SME compliances, those are part of manufacturer and private player, and for that, industries are fully developed those capabilities. Okay. Same ASME, oil and gas, I think L&T is dominating US market, 50-60% reactor, thick reactor, 300 thick, 200 thick reactor. We are supplying, beating all Italian, Korean. So on that side, but as a, I think, country level, what is decision is that this core nuclear physics, nuclear technology will remain with a GOI organization. There are some engineering company, in fact, it was debated in why not L&T should try to develop that. But finally, it is right now, there is no such policy where this thing will come to private. But as a capability, if sometime in government of India is deciding to have some support from private industry, I think private industry will be ready. There are strong JV like L&T's S&L. S&L is the core designer of all Canadian plant. And we got a JV with S&L, but for thermal power plant. There is no, but if really we need, then they have to take it in authorization and they can start supporting us.
Okay.
But other than nuclear technology, core physics, all balancing industry is ready, they can do.
And another thing is, I think you have been manufacturing, I know that was an excellent presentation made on the manufacturing side of the nuclear components, basically. For this so-called small nuclear power plants, which is going to be owned by the private parties, the size of this components is going to be different, or how it is going to be small?
No, so right now, what is being talked is 220 BSR, which is proven. So size and all those things known to everyone.
Okay.
So it's the word is small reactor, but it's our own existing 220 megawatt PSWR. So
okay,
it's the same. There's no change. Further, smaller one is under development. I think no private sector. In fact, they are not very happy with even 220 in terms of cost viability. They are saying now they are working on. They are saying they need twin unit of 700 rather than 220 because 220 smaller the reactor cost will go up. So we said you try out 6 into 220. Almost same time. Whether 6 into 220 is making sense or 4 into 220 is making sense. Same time, bigger reactor, they face a challenge that suppose steel plant they are supporting with 700 megawatt, 1700, and it's shut down, where they'll go. So ideally for them is 106 reactor. But cost should be equivalent to large reactor. So this problem, how we are going to solve, we don't know. Or then that combination where twin unit of 700, they are putting in grid and from grid they are getting rather than captive. Right now, what is approved is only captive power plant. They cannot sell electricity, they cannot put in grid also.
Okay. Thank you for that wonderful presentation.
Thank you. Thank you, sir.
Any other question?
Okay. So I just want to make one remark.
Sir.
You said that 700 megawatts or it need not be captive. The power can be fed to grid and they can take the grid as they want. That is what, when I said that we have to think in terms of integration of the energy system through electrification. Government is also telling that we need hydrogen.
Correct.
Hydrogen for industry. And they are thinking storage and hydrogen generation in two isolated compartments. One group is looking, one silo is looking at storage and one silo is looking at hydrogen. So I look it together. Whenever there is excess electricity in the system, run electrolyzer. It's a low-cost equipment. It can be ramped up and down and produce hydrogen and store it for use in industry. And whenever the demand of electricity is there, then supply electricity. So essentially, I'm saying that use hydrogen electrolyzer for shaping the demand in such a way that the supply and demand are equal. So for this, the government has to do two things. One, change the definition of green hydrogen to low carbon hydrogen. They can have a yardstick to how many carbon emission per unit of electricity generated. So nuclear will qualify for that along with solar and wind, and we will be able to do demand supply balancing by this electrolyzer. And second thing which has to be done, create a proper framework for marketing of hydrogen. That is the way forward, which other countries are thinking like this. And this is something which we have done detailed modeling for this, calculations for this. This This is where we have to move.
I think transportation is also some challenges they are facing.
Transportation, hydrogen, yes. So there, I think converting to ammonia and
Ammonia, liquid ammonia, then taking there.
liquid ammonia.
So
That is the way
correct.
forward. But this 700 megawatt larger reactors will be cost effective, and the way
Correct.
forward is
But
to think in terms of
what I was saying, sir,
balancing by electrolysis.
what I was saying in present policy, what government has issued for private player, that 700 is not there. So they are putting through, I think, NPCL that demand. We need option of both 220-700 because they are finding 700. But in what present expression of interest is only 220. There is no option of going to 700 for them.
They are asking for only 220 megawatt.
Correct.
It is too big a unit for them to start.
Because of they want a smaller unit, but now they are finding 220 calculation wise not cost effective. So but for sure they need nuclear energy. For sure they need clean energy because CBOM is like it's a 2 year. They are going to hit.
That is going to hit the only very soon.
27.
Yes.
27, 28. And that we are predicting based upon past. With Trump, it can happen any day. One day morning, yes, one day morning, EU Union can wake up and say, from tomorrow there is CBAM. We cannot predict.
The industry has to lobby with the government to change the definition of green hydrogen.
Correct.
I have one, sir.
Yeah, please.
Yeah, I have one small question about your presentation, wherein you brought out the leveraging of all these technologies, that is AI or robotics and so on, for example, for evaluating NDT results or for metrology using laser scanning and all that. Are they the results now? Are they benchmarked, and now can we completely rely on that?
So UT, sir, PAUT and TUFD we have done, and extensive thing along with third party like Lloyds, BB, who have been deputed by this oil and gas company. Then when all 100%, we said ki it should not miss. It can give some noise as a defect. So we are there where because of that, like 20% of thing we have to evaluate because some noises are also being given by that program as a defect, but it's not missing a single defect. An extensive thing has been done along with our data, past data with this thing.
You have done it for any NPCL?
No, because NPCL is A-scan. So this is implemented POT. A-scan is basically by hand you are scanning. So right now project we have given for A-scan to IT Chennai. Once we are through, we have just informed NPCL we are working on this technology. In fact, that day CMD also we presented. We have given project, but it's a primitive stage. We said like reactor header where 392 joint and each joint is so many probes. It minimum 3 weeks. One NPCL inspector is practically from morning to evening. He is standing there. I'm sure it's a very monotonous job for him also. Every day morning and 5. But there is no choice. He has to see. He cannot avoid seeing. So he is practically 8 hours means lunch and hata this. Udhar बैठ करके he keep on seeing his screen.
But
and one person.
Time, this will
so
happen.
This type of thing we are saying is for sure. We did in an NSEAL where recordable UT, immersible. So immersible technology is available, but for suck seam and overlay, immersible is not possible. Or you make such a big tank. Even I told my team, I can put reactor header in a tank. You try to do immersible technology possible for reactor. It's not a big thing. You can make a big tank where it can be, and then contact sensitivity can be done. But we are working. Because in my opinion, one of the bigger constraint in an NPCL program will be NDT and inspection. So NDT inspection automation, it will give 100% access to them at any point of time. They can access reference to the actual data. After 5 years also, they want to see exact what was the PSI time, inspection data. Is there any point close to deviation, which is now becoming a deviation? All the surface data, everything will be available.
Thank you.
So we are working on that on NPCL project.
So
you were referring to that why the 200 BSR is being offered, not 700. I mean, you people may be knowing better, but what I understand is the requirement of a smaller exclusion zone with some modifications. So that is one is getting fulfilled. Less capital requirement compared to 700. So these are some of the things actually government wants to.
I agree, but
make the private players show the interest so that at least things can be rolled. Perhaps gestation period also will be related.
yeah, I agree. But right now, what I was telling, there is a murmur among the private player to go to 700 rather than 220 because they are not finding commercially viable. And I'll tell you, investment, I don't think these big players whom name we are talking, they are having any issue of investment. They are not. We are not talking up.
They wanted to house it in the play. I mean, where thermal power plants are now getting retired.
In fact, they are saying, talking whether we should talk to NPCL that your land which you have acquired, you are not using it. Can you give it to us and we'll put investment to 6 number of 700 in that facility. So correct. I mean, they are those type of innovators. I mean, they'll be pitching somewhere, some political, some कहीं पे जाके बोलेंगे ये क्यों नहीं हो सकता वो क्यों. But they are right now. Good part is that at least these are people who are basically seeing how to make money. That mind started working how to bring cost and how to make competitive. So earlier NPCL, BRC and DA ko sochna tha how to bring cost. Now there are big players who have done in their life this thing. They are working. I am sure they'll find out some innovative solution in terms of funding, in terms of land, in terms of everything, in terms of technology. They got access to all foreign technology player and they are so big. All these technology player who talks differently to us, when they talk to these people, they talk differently because they are so big. So I am sure at least the direction is correct to involve private to start discussing. We have to wait and see.
A small question.
Yeah.
So you are talking about a lot of automation and improvements in your manufacturing sector and other things. And we talked about energy transition also. But in your manufacturing industry, how are you planning to reduce the carbon footprint?
So I just said I thought ESG already. I told third is most important is ESG, and we started monitoring ESG. We took a target 50% power of Hazira campus through solar. Why 50? Because Gujarat government was allowing only up to 50%. We reached 50% very fast. Then we approached, but that way Gujarat government was very supportive. They said we'll increase that limit. Right now we are at 66-70 and we target 85% of power consumed will be only solar. So all our shops with a solar panel and all those things. We have put hydrogen plant in our premises. There were two things. One is proving the technology and showing, because everyone says pehle dikhao to reference plant. So we thought we'll invest. So a small plant, 1 megawatt, but 1 megawatt hydrogen plant we have made in our premises. Using that hydrogen blending with NG for doing heat treatment. So our furnaces are using those hydrogen. Yes, our own electrolyzer division. We got a manufacturing facility at Hazira. It is a technology tie-up with McPhee, France, and we are doing manufacturing in those electrolyzer. Our capacity right now is 4 megawatt, and with a one shop. All furnaces we are changing and making smart furnaces so that gas consumption, all welding power sources is converted into AC/DC so that power consumption less. So massive towards ESG. And since I have to get a score, these things are monitoring, like water consumption per crore of sales I am monitoring. Energy consumption per crore sales I am producing, I am monitoring. Number of tree plantation, in fact, सभी भी guest आते हैं और भी हम लोग लगवाते हैं क्योंकि number of plants we are monitoring how much, because we get some credit for plant also. Then carbon emission per crore of sales I am doing. So those are structured we are monitoring. Even corporate level we have to report, because at the corporate level also there is a ESG target.
Maybe you can go for a micro reactor. That's what she's trying to say.
So Mr. Parav, I think spoke to Mohanty Saab ki if you can provide me smaller reactor, तो मेरा campus itself because of forging is electric arc furnace. 10 even 55 gigawatt 55 megawatt का plant Hazira में छोटा पड़ेगा. So much energy consumption. MNS is also electric furnace.
Then you take a 220 directly.
If MNS is with us, for sure, both are neighbor. MNS is electric furnace. Entire steel plant is MNS.
Mr. Bala,
Yes, sir.
Mr. Bala,
ahead.
can I say something?
Yes.
I think a question was asked about 220 and 700. Why not go to 700? Why the NPCIL's present RFP is only for 200? I think it all started under the political announcement of Bharat small reactor. So traditionally, what I understand is that the definition of small reactor is up to 300 megawatt. So I think
Correct.
220 was fitting into that model very well. So that is how my understanding is. And that is partly answer to maybe Mr. Ingole's question that why not 700 or other things. Thank
Correct.
you.
Right now, that is the thing. But I'm saying they are saying, is it any possibility of going forward 700? Today they are working with 220. I think all those expression of interest with 220 megawatt only.
Yeah, but then it does not fall in that propaganda or campaign of small reactor SMR. Then it is 700
Correct,
is
sir.
there any other, reactor which we are having plenty, 7, a fleet of 10 and others, imported reactors of
Correct,
higher.
sir. But private sector has no interest whether it's BSR, BSMR. They want energy to for solving their CBOM problem. Whether it's coming from 700 or 70.
Fully agree.
Correct.
Okay. Yeah. Thank you.
Thanks, Mr. Bhatt.
Yeah. Thank you, sir.
Mr. Bhatt, just now you said that Gujarat government is very supportive and they are allowing even 80% solar. So a lot of time we talk about the negative points of solar. You don't face any of the problem which we talk actually. That why we
So our is not like a continuous base load type car. We are a manufacturing industry. So plus we got our own alternate arrangement. Suppose furnace I need when I'm doing heat treatment I need continuous. That time
you don't need continuous.
We don't. We are not process plant. We are manufacturing an ETO type. So we don't need that type of energy.
Okay. One last question.
Sir.
So my question is regarding this establishment of new power plants. One is important aspect is the erection and commissioning part also. Anything you have to add to that?
So we say as a L&T end-to-end solution. So we are working out with our heavy civil group and PTND group to have same type. Like I am saying, I am going from 0.7 gigawatt to 2.1, at least 3 times on nuclear island side. Similarly, we are talking to them to triple their capacity. Fortunately, in his field, there are still some people who have done plant, at least SCC, FCON, I don't know, there are people who are competing, even new Omega is there. So, but he is also tripling and very encouraging that even civil people are working on this. We thought civil is typically traditional, but concrete pouring, all concrete pouring machine connected to IoTs, all those things, even they are going faster than mechanical industry. When I went and saw that, all those automation, in fact, a post office, they made it within a month with a 3D printing. So they are going in those direction. Modular, they are working a lot, how to do modularization. So I have not spoken to PTND because transmission part is, I think, matured and there are a lot many player transmission side. But civil people for sure they are working how to triple the capacity. One struggle I understand that is electrical side because we sold that business EBG and now Snyder is supporting the program. So that is one concern. So we are saying, can we have that capability for nuclear plant, whether in-house developing for nuclear plant to electrical capacity or have a good tie up some good company whom we can then we can give solution. Otherwise, civil side, mechanical side, commissioning, all those things we are working out. Automated. So site ka jo pipe ka welding hai, wo sab orbital welding, all those things we are working out. In fact, that famous tech tube ka bend, we told Padak Sahab ki we'll be doing that mock-up on our own to see that we can produce those bend here rather than going to Italian company.
So thank you. I request Dr. Gopika to, can request him.
May I request Professor Bandyopadhyay to propose a vote of thanks.
It's my privilege and honor to propose a vote of thanks here. On behalf of INAE and INAE local chapter Mumbai, local Mumbai chapters, I first of all thanks all of you to attend this very important talk, and also special thanks to Mr. Bhatt for presenting such a nice talk and talking about it. I'm also thankful to Mr. Bala, Dr. Grover, and everybody that are present today. So thank you very much.
Thank you, sir.
So I think with this we close this webinar. Thank you very much once again, all of you. Thank you.
Thank you.